Hey guys, this is Miss Goss. We're going to measure elastic force today. And if you look here, we have different things that you need to consider. Stretching distance, and that's how far we're actually going to stretch the rubber band. That is my independent variable. If you remember in math class from Mr. Fee, independent means that you control this one. Dependent is what the results of what you're getting, okay? So if you'll look here, obviously at 0, my force is going to be 0 newtons. We always measure in newtons, okay, even though there's pounds on this side. What I'm going to do, I'm going to stretch it to 2 centimeters, and I'm going to look here, and my stretching force is 1.25 newtons. So 1.25, I would record it. Then, same thing, I'm going to stretch the rubber band till it's even with the 4, and that is 2.25. And I'm not going to move that so you can see it every time. I will come back to it. At 6, mine is 2.5 newtons. Let me let it go. Then I keep going every 2 centimeters. Then it goes to 3. And so you see here, guys, if you pay attention, sorry about my little scratching here. This one increased 1 newton, but then from here on, it did not go up by 1. Okay, so there may not be a straight, there may not be a pattern to it. You don't look for patterns. You just collect the data that it gives you. Here, I've got 3.25. I'm going to stretch to 12 centimeters. When I stretch to 12, it's 3.5. I'll let it go all the way back, and I still make sure that it's on 0 here, guys, okay? If not, I re-zero my device. Okay, I pull it back. I've got 3.75. I stretch to 16. And I know my thing's getting out of the view. But I've got 4.0 newtons. Okay, I'm going to move the paper back so you can see what I'm doing. Then I move it to 18 newtons. And yes, this is where kids normally get scared. Miss Goss, is the rubber band going to break? Nope, it's not going to break on me. This is 4.5 newtons. And then I go all the way to 20. When I go all the way to 20, that's 4.75 newtons. All right. Then, and I'll have y'all do this probably as a discussion, okay? It says, what happens to the force required to stretch the rubber band when the stretching distance doubles, okay? So doubling means going from 2 to 4, okay? So you're going to look and tell me what happened whenever it moved from 2 to 4. Then find another place where it doubles. Okay, that could be 6 to 12. Did it go up by the same amount, or did those amounts change? And then you could go from, say, 8 to 16 or 10 to 20. But figure out and see if there is a pattern in what happened. Did it always go up, or was there any time that the stretching or the elastic force actually went down? okay? And I will tell you guys, if I took this same rubber band here and I do it again, because things are elastic, they tend to, the more you stretch them, the easier it gets, okay? So whenever I stretch this on out all the way to 20, and then I wanted to take and do it with my second block class, for instance, if I use that same rubber band, they're going to get different data here, okay? Just because, hey, the rubber band's already been used, okay? So that being said, like I probably will have this listed as a discussion, and I will give you the actual data that I have collected. But I kind of wanted you to see this little activity. I know it's kind of hard to see on the Elmo here because it's just a small little area, but I hate for y'all to miss out on all the labs. So anyway, if